Hi there, everybody. Welcome to part 2 of dimensional analysis and unit conversion. So if you haven't viewed part 1 already, I would strongly encourage you to go back and check that out because that laid a lot of the groundwork and the theory that we need in terms of unit conversion. We also talked about our prefixes and we talked about the base units, which we're going to be using a lot because we're going to be practicing in this session, which is part 2 of unit conversion and dimension analysis. I also would encourage you to potentially get a calculator. I have these problems worked out, so I'm going to be putting them down and walking through them with you together. However, you, as you're going along, should be working with me. And the first few you could probably get away without a calculator. After that, you will most definitely want a calculator. So I would encourage you to pause the video, go grab a scientific calculator if you don't have one, and then go ahead and get started. So, what we are going to do in this lesson, again, you should have seen the previous lesson, or you should be comfortable with unit conversion and dimensional analysis in the first place. We're going to be practicing, just straight practice for this lesson. So let's go ahead and get started. All right. So the first one that I have is to convert, give me a second here to bring my pen up. All right, so convert 3.55, what do I have, grams into kilograms. Okay, grams into kilograms. So what I'd like you to do is convert 3.55 grams into kilograms. Now for each of these, what I'm going to do, I'm going to continue to walk through it and show you the solution. However, I think that it's a very good idea for you to pause the video, attempt it yourself, and then you can see and come back and work through it. If you want to just work through it and that makes you feel better, you're welcome to do that, okay? And go through it as I'm working with it here. So what's the known when I set up my canceling table? Well, in this case, I've got 3.55 grams as my known. I'm going to want to cancel grams, and I'm going to want to end up in kilograms, so I know my grams will cancel. Now, this is where students tend to get lost very, very often because they don't know what to put on the top, what to put on the bottom. And they'll always get confused. Do I use a negative exponent? Do I use a positive exponent? What direction am I going in? There's an easy way to deal with this, okay? And you can do it however you want. You can multiply by negative exponents. The way that I like to do this and the way that I teach my students in lecture, you should always assign a 1 to the larger unit. So the question here is a kilogram or a gram larger? Hopefully you realize the answer is that a kilogram is larger. So we're going to say 1 kilogram, whatever unit's larger. So if it was milligram and gram, gram would be larger than a milligram, so it would be 1 gram. Okay. The key is if you're going to do this methodology, if you're going to put a 1 by the largest unit, the next thing you need to do is then in the opposite position, wherever that is, whether it's on top or bottom, use the base unit conversion for what you're doing. So we're working with kilograms and grams, so the difference, the absolute difference between those is 10 to the third. Okay, so go back to that first video, pick out a chart or use your book for your prefix conversions. You should see that the kilo prefix is 10 to the third when we're working with it. Okay, so what I end up with here, if I solve for this, is I get 3.55 times 10 to the negative third is what you should get if you put that into a calculator, and that is in kilograms. Now to the negative third is a smaller number, right, than 1. So if I take a look at that, that makes sense because grams, I'm converting into a larger unit, kilograms. So if I have a large amount of grams, I only need a very small amount of kilograms, which is a larger unit, to make up those grams. And so this is the proper answer. You could also get, and you may also get, so or okay, 0.00355. Now, we have not talked nor are we going to talk about significant figures in this particular lecture. We have one coming up soon on that. However, this would be the proper number of significant figures in this case because you start with 3 over here you end up with 3 in this answer when you're multiplying. These are just conversion units. Okay. The key here, because what we're really focused on is unit conversion practice, is that I ended up in kilograms by canceling grams, and I ended up with the proper amount when I worked with this. So what does 1 over 10 to the 3 represent? 1 over 10 to the 3 is the same thing as saying 10 to the negative third. So you would get the same answer if you took 3.55 times 10 to the negative third. And some people may do that. If you're comfortable with exponents and switching them when you need to, I encourage you to do it. You're welcome to do that. Many students have trouble when to keep it positive, when to keep it negative, right? Because if you go and you just look up the kilo prefix on a table, it says 10 to the third. That's relative to the base unit, right? So it's saying 10 to the third base units are going to make up 1 kilo unit. So you have to understand what you're working with here. We're saying we want the kilo unit, so the base unit, that means it's going to convert it into a smaller number because kilo units are larger, and we're trying to keep these proportional to one another, if that makes any sense. Okay, so, and I'll explain that again when we get to the next example here. So this would be the answer for the first one. All right, so let's do the next one. The next example I have, and by the way, these are all intra. In other words, I'm going from gram to another form of gram, kilogram. This is also going to be an intra. We will do some inter at the end of this lesson, but this is intra again. So convert 6.2 meters, and I'll abbreviate that with M, to millimeters. All right. So again, I start with what I know. I know that I have 6.2 meters, and I would like to turn that into millimeters, so I'll get rid of meters. This should always be the way that you set up your canceling tables when you start. The known, and then you put out the unit on the bottom that you want to cancel, on the top that you'd like to convert into. Now right now we're really doing sort of one-to-one conversions. We're not doing multi-step where we go 5, 6 along the pathway, or even 3 along the pathway. I'm just doing meter to millimeter, gram to kilogram, so on and so forth. So the question here is a meter or a millimeter a larger unit? A meter is a larger unit. Think about a meter stick, and then think about a tiny little millimeter. Very tiny. So the question is, what is the absolute value? We're not using negatives using this technique. What is the absolute value for the milli prefix relative to the base unit? It is 10 to the third. Okay. Now, again, students get confused when they go in and they look at the table because it says the milli prefix is 10 to the minus third. So you would be incorrect if you put 10 to the minus third up here. You would not get the correct answer. Okay. And again, you have to be careful. What that's saying is that 1 meter, 1 base unit, is 10 to the third millimeters. A bunch of small units need to make up 1 big unit. And then vice versa. Okay, so where's the negative third coming from? Well, what that's saying is that 1 millimeter, in reference to the base unit, is 10 to the negative third base units. Okay, so meters. Same thing could be done up here with the kilograms and the grams, right? So what it's saying is that 1 kilogram is 10 to the third grams, right? 1 kilogram is equal to 10 to the third grams. Whereas 1 gram is equal to 10 to the minus third kilograms. So you have to be careful. You have to be able to use your units proportionally when the case arises. Doing this, giving the larger unit 1 and then the smaller unit the larger number, always takes care of that for you if you're not comfortable with it. Okay? But notice when you go and you look at that chart, if you look up a chart with a kilo prefix, the kilo prefix is 10 to the third relative to the base unit. If I look up milli in a chart, it's 10 to the minus third relative to the base unit. So hopefully that makes sense to you when you're seeing this, okay? So if I set this problem up and I solve it, I should get 6.2 times 10 to the third millimeters, or 0.062. I'm sorry, there's another Give me a second. There's another 0 in there I missed. 0.0062, right? Because if I move the decimal 1, 2, 3 times, I get back to 6.2. So this would be in millimeters because that's the final unit. Okay? So hopefully you guys are starting to get a grasp on this and understand this. Let's practice a few others. All right. Convert. Oh, this is a good one. Okay, this is a little bit different than what we've been doing. So here I'm going to exclude the actual base unit itself and put them both with prefixes, and we'll work with that. So convert 4.57 nanograms into, what do I have there? Milligrams. All right, so the known here is going to be 4.57 nanograms. All right. Now, when I deal with this, I'm going to say I'd like to get rid of nanograms and go into milligrams. Now, I have to be careful because I'm not dealing with a specific base unit here. I do have grams as the base unit, but I don't have grams appearing in the problem. I have milligrams and nanograms, so I need to take care of that. The question is, first of all, which unit is larger, a milligram or a nanogram? And the answer is a milligram is larger than a nanogram. So 1 milligram. So then how many nanograms are in a milligram? You have to look at the absolute difference between the two on the chart. So if you go back to that first video or you look on your chart, you're going to see that milligram relative to base unit is 10 to the minus third, and that nano is going to be 10 to the minus ninth, again, relative to base unit. So what is the difference? What is the difference between these? It is 10 to the sixth, right? Talking about the absolute value, when we're taking the absolute difference in terms of the tens unit, we're dealing with 10 to the sixth. So 10 to the sixth nanograms in every 1 milligram, right? A bunch of smaller, a large number of smaller, making up 1 larger is what we're dealing with here. So nanograms are going to cancel, and what I end up with is 4.57 times 10 to the 6 nanograms. I'm sorry, nope. Times 10 to the 6, wait a minute. I'm sorry, times 10 to the minus 6. I'm not paying attention here because it's on the bottom, right? Times 10 to the minus 6 milligrams. All right, there we go. Small number of milligrams for a lot of nanograms, right? And that makes sense. If I start with nanograms, I want to go to milligrams. This should be smaller. That's always a good way to double check yourself. You know, I started tripping myself up. It didn't make sense. I need a small number here because this unit is larger, so I only need a small amount of it to make up whatever I had for the smaller unit. Okay? This then, especially at this point, because then if you're talking about not doing scientific notation here, what are we, to the 6? So 1, 2, 3, 4, 5, and then 6. This would be, without scientific notation, the proper answer. You can see as the number gets, when I say larger or smaller, extremely small or extremely large, you have a ton of zeros that are present before what we would call the significant digits. And so it's much cleaner to put this in scientific notation form than it is to keep writing it out like this. And you should get in a habit of putting your answers, especially if you go more than like 3 zeros, into scientific notation. It's a pretty good habit. All right. So then finally, let's do one more interconversion. So let's convert, all right, let's convert 6.12 kiloliters into microliters. So similar to the problem above, in that there's prefixes associated with both. Now I'm still using the same base unit, liters. So this is still an intra conversion, not an inter-unit conversion. So I'm going to go a little bit quicker with this one because you guys should understand where I'm coming from now. Okay, kiloliters. I'd like to cancel out kiloliters and go to microliters. So kiloliter is much bigger than a microliter. I'll give that one. And then the question is, if I look on the chart, okay, what is the difference between them? So if I were to look on that chart, I would say I have 10 to the minus 6 for micro. Then base unit is right here at null. And then the kilo is going to be 10 to the third. So if I take a look at this whole thing, I'm jumping 10 to the 6 as I go here, and then add an additional 10 to the 3 here. The total for that is going to be 10 to the 9th. Okay. Now, that's going to come out to be, and let's, you know what, let's actually, that looks a little too far down there. Let's make sure that's clearly an exponent, 10 to the 9th. Okay. So what I get is 6.12 times 10 to the 9th microliters. Now let's think about that. Does that make sense? That's an enormous number because this is saying there's 9 zeros that come after that too, right? So does that make sense? This is a kiloliter. That's a very large unit. So I have a very small unit. So yes, this makes sense. I want lots and lots and lots and lots of small units in order to make up several of my big units. So I do need a large number here. This does make sense. And again, I'm not going to go and show you the actual with all the zeros after it. At this point, you should be sticking to scientific notation when you're on that sort of scale. Okay, so let's take a look at, we'll do two inter conversions. And there is something I want to bring up when we're working with this. So let's convert 15 inches into, we're going to do it into centimeters. 15 inches into centimeters. Okay. So here, I know that I have 15 inches. I want to get rid of inches, and I want to go to a centimeter. Now, you may have some trouble here because we're no longer just talking about the prefixes, right? At this point, we're talking about two different units. So is an inch longer or is a centimeter longer? And when you get into this, you want to have a proper unit conversion table. So what I'm going to do, I'm going to show you guys real quick. Let's bring up Google. And you can just type in, yeah, I already have it there, unit conversion table. Okay, I usually go to like the images and pick out a unit conversion table. I think I used this one in the old video. So here you go. Okay, you can see this here. Let me go ahead and put that on the page there. So hopefully you can see this. Take a look at 1 inch is 2.54 centimeters. So the question is, which one of these is larger? An inch is larger because 1 inch is 2.54 centimeters. So 1 centimeter is smaller than 1 inch because I need 2.54 of them in order to make this up. So it's very important that you have a good chart like this handy when you want to go back and forth in between those types of conversions. On a test, I mean, for my specific test, I let my students utilize a table like this. You should, at most places, get access to some sort of a table like this. You should not be memorizing this kind of stuff. You do need to know how to convert properly, okay? But you should not need to spend your time memorizing all this. The prefix units, maybe. They may ask you to memorize those because we use them so often. But to arbitrarily remember, you know, centimeters and an inch is fairly common, but kilometers and a mile, grams and a pound, that's not stuff you use in everyday life, especially when you're starting out as students. You know, as an instructor, you may come across it enough. But so 2.54 for every 1 inch. So let's put that in there. And we're going to have to go back to that table on the next problem, so we'll keep it minimized. Okay. So we said for every 1 inch, because inch is the larger unit, there are 2.54 centimeters. So now, this is the first problem where I would argue you really need your calculator, because I'm not just changing the exponential prefix on the base unit. I'm actually going to a different unit and it's going to have a completely new number. It's not just a 10 base unit here, right? There's an actual number there. So multiply that, and what you should get is 38.1. Right? That's an ugly 3. Should get 38.1 inches dropped. So that is in centimeters. Reminder again, we're not talking about significant figures this round. We're just talking about unit conversion. Okay? So now that we've checked, does this make sense? Well, centimeter is a smaller unit. So yes, I need more centimeters than I have inches in order to make this conversion proper. And that's correct. It's almost 2.5 times 15. So 2 times 15 would be 30. 2.5 times 15, we're getting close to this value here. All right. So then finally, let's do one more here. Let's convert 429 gallons into liters. All right, so set it up. 429 gallons. And then the question is, which one is larger? So let's go back and reference our table. 1 gallon is 3.785 liters. So a liter is smaller than a gallon. I need several liters in order to make a gallon. Okay, 3.785. So I want liter up here. 3.785 liters for every 1 gallon. So go ahead, plug that into your calculator. Again, ignoring sig figs, just working on the unit conversion, you should get 1,623.7 liters. Okay? So hopefully you guys found this useful. Again, if you need more reference in order to solve these, you should go back and watch the first video. You absolutely need to be practicing this, and not just for your first test. You really need to be practicing this on a regular basis because there are going to be many, many unit conversions that come up throughout the rest of general chemistry. It's not just going to appear on your first test, I promise you. Every single unit you're going to be dealing with these types of conversions, whether we're going from grams to moles, that'll be one of the first ones, moles to atoms. We may start dealing with energy unit values when we're talking about joules, when we start talking about enthalpy and whether something's endothermic or exothermic, and how much energy does a mole of a certain compound give off when it's combusting or when it's being burned. And so this technique and this practical math skill will be applied throughout all of general chemistry. You will see it come up over and over and over again. So get that rusty algebra up to snuff when you're doing multiplication, division. Make sure that you are doing lots of practice with this sort of stuff. Okay, so this entire video was nothing but practice on unit conversion because I want you guys to get a lot of practice with it. So that about does it for the second part of unit conversion and dimensional analysis. So what do I have coming up? It looks like we're going to do precision versus accuracy and error and how those all interrelate to one another. And then we will talk about significant figures. That's very important. So we need to do sig figs. I might throw in a little scientific notation into that as well. So those are the two major units coming up. And then after that, we will really be done the introduction portion of general chemistry, and there's still a lot of stuff we're going to get to cover, but then you get into more of the actual chemistry content versus the mathematical conversions and things like that. So we'll start talking about protons, electrons, the structure of an atom, moles. We'll start calculating grams to moles, like I mentioned, density, all that kind of stuff. So I hope this was helpful. I will see you guys for the next video. Please remember to like, comment, and subscribe if you found this helpful. It helps me build up the channel, get a following, get some more attention out there, because that's what the mission is really about. It is trying to deliver online content so you can learn when you're ready. You know, I know everybody has lectures in the classroom when you're learning, but you should have access to high quality material at any point so you can learn on your own schedule and go in and really show your instructors you know what you're doing. Okay? So other than that, I hope you guys have a great rest of your day, and I will see you for the next lecture. Take care.